Hey guys, in this video we will be going over how to add, subtract, and multiply radicals. So just like we can add and subtract like terms, such as 4x plus 6x, where we add the coefficients of the terms and then multiply the result by the variable, we can also add and subtract like radicals, such as 4 square root of 3 plus 6 square root of 3. Like radicals have the same index and the same radicand. Some other examples of like radicals include the following. And we consider these like radicals because they have the same index and the same radicand. So for this video, we will assume that all variables represent non-negative real numbers. In order to add or subtract radicals, they must be like radicals. So we add or subtract the coefficients of the radicals and multiply the result by the radical. So let's do some examples. For this expression, notice that the radicals have the same index and the same radicand. Therefore, these are considered like radicals and can be combined. So we add the coefficients and multiply by the radical. So this simplifies to 10 radical 3. For the next example, again notice that the radicals have the same index and the same radicand. Therefore, these are like radicals and can be combined. So we subtract 1 minus 9, which is negative 8, and then multiply by the radical. Therefore, this simplifies to negative 8 times the fourth root of 5. For the next example, although the radicals have the same index, they do not have the same radicand. Therefore, these are not like radicals and cannot be combined. The expression is then already simplified. For this expression, notice how there are two different types of radicals, square root of x and the cube root of x. We can combine these two terms, which will give us 8 square root of x, and then we can combine these two terms, which will give us 5 cube root x. And these radicals cannot be combined further, and since they are in simplest form, the expression is now simplified. So sometimes it may appear that two radicals cannot be added or subtracted, but if the radicals can be simplified and they turn out to be like radicals, then we can add or subtract them. So the procedure to adding and subtracting radicals is to first write each radical expression in simplest form, and then to combine the like radicals. So for example 2, the radicals are not like because the radicands are not the same. The first radical is in simplest form, but these two radicals are not and have to be simplified. 50 has a perfect square factor of 25, and 45 has a perfect square factor of 9. Use the product rule and simplify. So the square root of 25 is 5, and the square root of 9 is 3. So we have 8 square root 2 plus 15 square root 2 minus 3 square root 5. And now notice that these two radicals are like radicals and can be combined. Therefore, this expression simplifies to 23 square root 2 minus 3 square root 5. And for the next example, again, the radicals are not like because the radicands are not the same. Therefore, we will have to write the radical in simplest form to see if they turn out to be like radicals. 40 has a perfect cube factor of 8, and now use the product rule and simplify. So the cube root of 8 is 2, and then we can multiply negative 7 times 2, and now we have negative 14 cube root 5 plus cube root 5. We now have like radicals, and these can be combined. So this radical has a coefficient of 1, therefore this will combine to negative 13 cube root 5. For this example, again they are not like radicals, so let's try simplifying them first. The radical 2x is simplified, but radical 8x is not, so we must simplify this. 8 has a perfect square of 4, and then we use the product rule and simplify. The square root of 4 is 2, multiply 10 times 2, and we get 20 square root 2x minus 9 square root 2x. And now we have like radicals. Therefore, this combines to 11 square root 2x. For this example, again, we first need to simplify the radicals. We'll have to rewrite x to the 7th so that one of its factors has an exponent that's divisible by 3. So x to the 6th times x. And now using our product rule, we can simplify. So the cube root of y to the 6 is y raised to the 6 over 3, which is y squared. And the cube root of x to the 6 is x raised to the 6 over 3, which equals x squared. And now we have like radicals. However, we can't actually add x squared and y squared like we added in the previous examples. The only thing we could really do is factor out a cube root of x. So we can rewrite it in the following ways. Okay, now let's go over how to multiply radical expressions. And we do this by utilizing the product rule for radicals. So let's begin with multiplying a binomial containing radical expressions by a monomial. So to multiply this, we distribute the 4 to each term. And now we simplify. The square root of 20 can be simplified since 20 contains a perfect square factor of 4, so we use the product rule and simplify. The square root of 4 is 2, and then multiply the 4 and 2, and our expression becomes 4 square root 5 minus 8 square root 5. And it looks like we have like radicals, so let's combine these. And now our expression simplifies to negative 4 square root 5. For the next example, we distribute the square root of 2 to each term. And we can use our product rule to write each of these as one radical and multiply the radicands. So the square root of 20 can be simplified since 20 has a perfect square factor of 4, and the square root of 30 is already simplified since it does not contain any perfect square factors other than 1. So the square root of 4 is 2, and now our expression simplifies to 2 square root 5 plus square root of 30. And we do the same thing for this example, so we distribute the square root of x to each term, and then using our product rule, we can rewrite these as one radical. We can simplify the square root of x squared, since this is the same as x raised to the 2 over 2, which is just x. And we could also simplify the square root of 32xy, since 32 has a perfect square factor of 16. And then using our product rule, we can simplify. So the square root of 16 is 4, and our final expression simplifies to x plus 4 square root of 2xy. Now let's go over how to multiply two binomials containing radical expressions. Recall that to multiply two binomials like 2x plus 3 times x plus 4, we would have to distribute each term in the first binomial to every term in the second binomial, and then simplify by combining like terms. We do the same thing with radical expressions. So to multiply these two expressions, we would have to distribute each term in the first binomial to every term in the second binomial. And then we can combine these two radicals since these are like radicals. And then using the product rule, we can rewrite this as the square root of 25. The square root of 25 is 5, and we can combine the 8 and the 5, and our expression simplifies to 13 plus 6 square root 5. For the next example, again to multiply this, we would have to distribute every term in the first binomial to every term in the second binomial. And now let's simplify. So we get 2 square root 9 minus 2 times 5, which is 10, square root 3 times square root 2, which is square root 6, plus square root 6, minus 5, and square root 2 times square root 2 is square root 4. Square root of 9 simplifies to 3, and we can combine the like radicals in the middle, and then square root of 4 is 2, multiply this out and simplify, and we get negative 4 minus 9 square root of 6 as our answer. And we do the same thing with this example. So let's just take a shortcut and multiply the radicands in the first step. So the square root of x squared simplifies to x, and the like radicals combine to 9 square root of 3x squared. And we can simplify the square root of 9x squared as 3x. We can still simplify the square root of 3x squared since we have a perfect square factor of x squared. Combine the like terms, and this simplifies to 25x plus 9x square root 3. Let's also multiply the square of a binomial radical expression, as well as a sum and difference of radicals. So for example 5, in order to multiply this expression, we can expand this as 2 factors of square root 10 plus 3. And now we can distribute each term in the first binomial to each term in the second binomial. So the square root of 100 is 10. The like radicals combine. And then we can combine the 10 and the 9. So we get 19 plus 6 radical 10 as our answer. And to multiply this next example, again we distribute each term in the first binomial to every term in the second binomial. Square root of x squared is just x, and we can combine the like radicals. This actually cancels out, and then the square root of y squared is just y. So our expression simplifies to 4x minus y.